Day 18 of 90. During incident response and penetration testing, the first thing you need is a clear picture of the system you are working with. OS version, network configuration, local users, installed software. These data points inform every decision that follows. Today we are building Python scripts that collect all of this automatically and output structured JSON that you can diff between scans. Let us start with OS fingerprinting. Python ships with the platform module in the standard library, so no pip install needed. You call platform.system to get Linux, Windows, or Darwin. Platform.release and platform.version give you the kernel version and build string. Platform.node gives the hostname, and platform.machine tells you the architecture, x86_64 or arch64. On Linux, I also read /etc/os release to grab the pretty _name field because just knowing it is Linux is not enough. You need the distro and version. Ubuntu 22.04 has different vulnerabilities than CentOS 7. I wrap all of this into a dictionary with a UTC timestamp so every scan is dated. The output goes to JSON because structured data is diffable. Next up is network interface enumeration. For this I use psutil, which gives you cross-platform access to NIC data without shelling out to ifconfig or IP address. The function psutil.net_if_headers returns a dictionary where keys are interface names and values are lists of address objects. Each address has a family, the actual address string, a net mask, and a broadcast address. I pair this with psutil.net_if_stats, which tells you whether the interface is up and its link speed in megabits. Why does this matter for security? During internal assessments, I have found interfaces bound to management VLANs that should have been segmented off. If an interface is up and has an IP on a network you did not expect, that is either a misconfiguration or something worse. Automated enumeration catches things that manual inspection misses. Now we get into user account auditing, which is one of the highest value local checks you can do. On Linux, the passwd module gives you access to the password database without parsing text files manually. You iterate with pwd.getWall and get back objects with username, UID, GID, home directory, and login shell. The grp module lets you enumerate group memberships. 2 flags I check automatically. First, any account with UID 0 that is not root. Attackers create backdoor accounts with UID 0 to get root equivalent access. This is a classic persistence technique. Second, service accounts with interactive shells. If a service account has /bin/bash instead of /usr/spin/knowledge, it means someone can log into that account interactively. That is unnecessary attack surface. These 2 automated checks alone have found real issues on production systems I have audited. Installed software inventory rounds out our collection. On Debian-based systems I use dpkg-query with a custom format string that returns package name, version, and install status, all tab separated. I filter for packages with status installed to exclude packages that were removed but left configuration files behind. But system packages are only half the story. Python library versions matter just as much. An outdated requests or cryptography library is a vulnerability even if every system package is current. So I also call pip list with the format JSON flag and merge that data in. On Red Hat systems you would swap dpkg-query for rpm-qa, and on Windows you read the uninstall registry keys under HKLM software Microsoft Windows current version uninstall. Finally, I wrap everything into a consolidated recon report. One function calls all 4 collectors, merges the results into a single dictionary, generates a SHA-based report ID to avoid filename collisions, and writes the whole thing to a timestamped JSON file. On actual engagements, you would encrypt this before storage because it contains sensitive infrastructure details. The structured format means you can load two reports from different dates and programmatically diff them to find changes. That is day 18 wrapped up. We now have a complete local recon toolkit that covers OS fingerprinting, network interfaces, user accounts, and installed software. Tomorrow on day 19, we will build on this by adding process enumeration and schedule task inspection. The data we collected today becomes input for those more targeted checks. See you then.